The following is a production of Woods Hole Oceanographic Institution.
A fraction of the ice that used to be on land in Greenland for a long time is now being flushed, dumped into the ocean, increasing the amount of water in the global ocean, and it's driving up sea level. Sea level rise is one of the most immediate concerns for global society associated with climate change. You're going to see more and more flooding. This has the potential to displace many people. So I'm studying the role that potentially the ocean has played in driving some of the changes that have been happening in the Greenland ice sheet. The North Atlantic is truly a special place in the ocean circulation because it's a place where a lot of heat stored in the ocean is released to the atmosphere, and as a result, the surface of the ocean becomes dense, and these dense waters then fill the deep oceans everywhere. The work I do is mostly focused at trying to get ocean measurements as close to the edge of these glaciers as I can, where literally the ice meets the ocean. Working in Greenland is wonderful some days, and it's the worst thing that can happen some other days. One of the most exciting and challenging trips I've made to Greenland was in Sermelik Fjord last winter. We don't have any measurements from these fjords in the winter, so it was scientifically really important. Every day I went down to the heliport hoping to fly, and every day I returned to the hotel because either weather was bad or they had to do a rescue mission. And after 5 days of just waiting, we finally found two people who live in this village who said, "We'll take you via land." So we set off two snowmobiles, and we're flipping over every other minute because the snow is so deep and so wet they would just sink. Shoveling out the snowmobiles was exhausting, and there were times when I just thought, okay, even for science, this is way too much. But then when I got out to the fjord, we shoveled out this little boat, and it was open water, and it was a beautiful day. And the fjord is this most amazing place. All the icebergs are now covered by 3 feet of snow. Their contours are incredibly gentle. Getting those measurements was very rewarding. But the upper quarter of the fjord is not accessible by boat. There's too much ice. And we were very lucky then because the last day, the helicopter pilot said, "Okay, we have an hour, jump on." I think we had the whole town cheering for us at that point. So we fly over this region that's completely covered in ice, and we spend a long time looking for patches of open water. Then we hover and we deploy probes. We throw them in.
Probe is at 400 meters, still going.
Oh. They scuttle all the way down to the seafloor. Everything is done within minutes. You just get one shot at it and things have to work. And so one of the things we found is that in winter, everything that we see in the fjord really just has to do with the ocean circulation. The ocean waters are warmer in the winter than they are in the summer. This warm water is coming from the Gulf Stream. It's being carried by the Gulf Stream towards Greenland, right up against the glaciers. Warm by Greenland standards, 40 degrees Fahrenheit, more than enough to melt the ice from underneath. And in summer, we've seen something completely different. As the air temperatures go up, it means that you're getting so much melting at the surface of the glaciers. And so you're generating these rivers of cold water that just come pouring down the ice sheet. Some of them at the surface, some of them find their ways in little channels and come down 2,000 feet below sea level. Taps of water gushing out that turn on in the summer. These fjords are dynamic. Many things are going on at once. And this is typical of climate. It's very difficult to pull just one process out. We know that the ice sheets have undergone changes in the past. On timescales that are hundreds or thousands of years or longer. But what's been happening over the last 20 or so years is these glaciers have just doubled the speed at which they're flowing into the ocean. They've shrunk. We didn't really know that things could happen this quickly. We're scrambling to try and understand what is going on. How do we connect the ocean and the ice sheets? How do we study and make sure that we know how one affects the other so that we can interpret the past and predict the future?
To learn more about Woods Hole Oceanographic Institution, visit us on the web at www.whoi.edu.